welcome to our deep dive today. I know you folks are really interested in getting a deeper understanding of ecological interface design, and, well, we've got just the thing for you.
Oh, is that right?
Yeah. Excerpts from a paper, a 1992 paper called Ecological Interface Design, Theoretical Foundations. It's by Kim J. Vicente and Jens Rasmussen.
Yes.
Yeah, it's a classic, it lays the groundwork for how we can design interfaces that really help operators, especially in complex systems.
Right.
Those high-stakes situations.
Yeah.
To handle the unexpected.
Things you don't expect.
Exactly, those curveballs.
Curveballs, yeah.
And joining us to break it all down is, well, an expert in human-machine interaction and design.
Happy to be here.
Thanks for being here. I'm really looking forward to unpacking this with you.
Yeah, it's, foundational paper for a reason, so let's get into it.
Yeah, let's dive in. So the paper starts by setting the stage. Unanticipated events in complex systems. So we're talking about like nuclear power plants, aviation, that sort of thing. They argue that traditional design approaches often don't cut it when these curveballs inevitably arise.
Mm-hmm.
And, they bring up a pretty chilling example, the 3 Mile Island accident, to really drive home the point that poor interface design can actually worsen a crisis.
Yeah, 3 Mile Island, that's right. It was a stark reminder, for sure. It's, how critical it is for operators to understand not just what information is presented, but what it means.
Yeah.
In terms of the system's underlying constraints. And traditional interfaces often fail to provide that deeper level of understanding, leaving operators ill-equipped to adapt to those unforeseen situations.
Yeah, you don't want to be in that spot.
No.
So to address this, they introduce what they call the abstraction hierarchy.
Okay.
I'm curious, how would you explain the abstraction hierarchy to someone who's never encountered it before?
Well, it's essentially a multi-level representation of a system. Imagine like a pyramid, with the system's overall purpose at the top.
At the top.
As you move down, you get more and more specific, going through like functional levels down to the physical components and their variables at the very bottom of the pyramid.
Okay, so instead of just seeing a sea of gauges and alarms, an operator can use the abstraction hierarchy to understand how everything connects, how those individual components contribute to the system's overall goals and functions.
That's it. That's exactly right. Yeah, it's about providing that big picture context, you know? That's so crucial for effective problem solving, especially when things go wrong.
Right, when those curveballs come up.
Yeah.
Now, the paper doesn't just stop at describing the abstraction hierarchy. They link it directly to how our brains work, bringing in Rasmussen's skills, rules, knowledge taxonomy, or SRK for short.
Right.
Can you unpack that for us? How does SRK fit into the picture?
Sure. So the SRK taxonomy describes three distinct levels of cognitive control. So at the skill-based level, we're talking about those highly automated actions, things we do almost without thinking. Like driving a car on a familiar route. Then you have rule-based behavior where we learn rules and procedures. Think of a chef following a recipe.
Right.
And then finally, at the knowledge-based level, we're in uncharted territory, dealing with those novel problems that require conscious analytical thinking.
Yep, that makes sense. So how does this taxonomy relate to interface design?
Well, the key insight is that different levels of cognitive control require different types of support from the interface. A well-designed interface should facilitate smooth transitions between these levels, allowing operators to seamlessly shift from intuitive action to analytical problem solving as needed.
So it's all about adapting to the situation.
Exactly.
And that leads us to the core of the paper, the concept of ecological interface design, or EID.
Right.
They propose 3 main principles, each tailored to support a different level of cognitive control. Let's start with the first principle, skill-based behavior, or SBB.
Okay.
What are the key elements of an interface designed to support SBB?
So for SBB, direct manipulation is key. The interface should allow operators to interact with the system in a way that feels, natural and intuitive.
Right.
Think of it as like a direct mapping between what you see and what you do. For example, instead of typing in commands to like open or close valves, an operator might simply drag a virtual valve on the screen.
Oh, okay.
So this kind of direct manipulation, reduces cognitive load and allows operators to rely on their their well-honed skills and reflexes.
So it's about making the interface an extension of the operator's expertise, almost like a skilled musician intuitively playing an instrument.
That's a great analogy.
Yeah,
That's what came to mind.
yeah, the interface should become like so transparent that it fades into the background, allowing the operator to focus on the task at hand. Gotcha. That makes a lot of sense. Now let's move on to the second principle, rule-based behavior, or RBB. What are the key considerations when designing an interface to support RBB?
So for RDB, the key is consistency and clarity. You know the interface needs to provide clear, unambiguous cues that trigger learned rules and procedures. The authors use the term procedural traps to describe situations where an operator applies a familiar rule, but it leads to an unexpected outcome because the interface doesn't provide the necessary context.
Right.
So a well-designed interface should avoid these procedural traps by ensuring a consistent mapping between system constraints and the perceptual cues presented to the operator.
So it's about building a visual vocabulary that accurately reflects the rules of the system, making those rules explicit and accessible.
Exactly. Think of it like a well-designed traffic light system.
Love it.
The colors and positions of the lights provide, clear, unambiguous cues that drivers can rely on to make safe decisions. An EID-designed interface should strive for that same level of clarity and consistency. So, welcome back to our deep dive into ecological interface design.
It's great to be back.
Yeah.
We've been delving into the core principles of EID and how they support those different levels of cognitive control.
Right.
Skill-based and rule-based behavior. But now I'm really curious about that third principle.
Okay.
Knowledge-based behavior. KBB.
Yeah.
Where things get really, really complex. The paper highlights how traditional interfaces often fall short when it comes to supporting KBB,
They do.
leading to those, oh no moments in those unpredictable situations.
Right.
So how does the abstraction hierarchy actually support KBB?
Well, remember, KBB kicks in when we encounter those novel problems. Situations where our existing skills and rules don't quite cut it.
Okay.
So we need to tap into our deep knowledge of the system, understand not just what each component does, but why it does it,
Right.
and how it fits into the overall function.
The big picture.
Exactly. The abstraction hierarchy provides that crucial context, allowing operators to analyze the situation, make inferences, and come up with solutions that go beyond those pre-programmed responses.
So instead of just reacting to alarms and trying to follow procedures blindly, the operator can use the abstraction hierarchy as a mental map to navigate the complexity of the system.
Right.
And make informed decisions.
Exactly. It's about empowering operators to think critically and creatively.
Right.
To become problem solvers rather than just button pushers.
I like that. I'm starting to see how this could make a huge difference in those high pressure situations.
Yeah.
Where quick thinking and deep understanding are paramount.
For sure.
But, how do we actually translate this concept of the abstraction hierarchy into a tangible interface design?
Well, that's where EID's third principle comes in, making that mental model visible. The interface should not just display raw data.
Yeah.
It should represent the system's functional structure, highlighting those relationships between components and how they contribute to higher level goals.
So instead of being bombarded with information, the operator has a clear, structured representation that guides their understanding and decision-making.
Exactly. It's about reducing that cognitive load and making the system's complexity more manageable for the human mind.
Right, right. The paper mentions how traditional interfaces often obscure those critical functional relationships.
They do.
Leading to, errors and misunderstandings, especially in stressful situations.
Yeah, think of a fault tree diagram that only shows the physical connections between components but doesn't reveal the underlying functional dependencies.
Right.
So an operator might miss a crucial piece of the puzzle.
Right.
Leading to a misdiagnosis.
Yeah.
And potentially disastrous consequences.
So an EID design interface would, in theory, equip the operator with a more complete and insightful view of the system, reducing the risk of those kinds of errors.
Exactly. It's about providing a scaffold for their thinking, a framework that helps them make sense of the situation and arrive at the right solution, even when faced with the unexpected.
I've always been fascinated by how our brains make sense of complex information.
Right.
And how interfaces can either hinder or facilitate that process.
Yeah.
It seems like EID is really tapping into something fundamental about human cognition.
Yeah.
This idea that we need more than just data. We need context.
Yeah.
We need to understand the why behind the what.
I completely agree.
Yeah.
And the beauty of EID is that it's, grounded in empirical research, in an understanding of how our brains work
Right.
and how we interact with the world around us.
Speaking of empirical research, the paper describes an experiment where they actually put EID to the test.
They did.
Can you walk us through that experiment and what they discovered?
Sure. They created two different interfaces
Okay.
for a simulated thermal hydraulic system.
Okay.
One interface, what they called the physical interface, only showed those physical components and variables,
Okay.
like valves, pumps, and temperature readings.
Gotcha.
The other, the physical functional interface, incorporated the abstraction hierarchy,
Right.
visually representing not just the physical components, but also the higher level functional relationships between them.
So it was like giving one group of participants a basic roadmap, while the other group got a detailed satellite image
That's a great way to put it.
with all the layers of information.
Yeah.
Okay.
So then they had both groups of participants, experts, and novices perform a series of tasks using these interfaces.
Okay.
One task involved recalling the state of various process variables after observing a dynamic event sequence.
Okay.
The other, and this was the real test of KBB, involved diagnosing the system state,
Okay.
whether it was operating normally, experiencing a fault, or behaving in a completely random, nonsensical way.
Wow. So they really threw them a curveball.
They did.
Okay. And what did they find? Did the interface that incorporated the abstraction hierarchy actually make a difference?
The results were quite striking, especially for the experts. The group using the physical functional interface, the one that represented the abstraction hierarchy, performed significantly better on that diagnosis task. They were able to accurately assess the system state even when faced with those random, unexpected behaviors.
So there's actual evidence that EID can improve problem-solving performance, particularly in those challenging, knowledge-demanding situations.
Absolutely. It's a strong indication that by making the mental model visible, by supporting KBB, we can empower operators to make better decisions
Right.
faster
Faster.
and more accurately.
This is all incredibly fascinating, and I'm starting to see the real-world implications, especially in fields like nuclear power or aviation, where even small errors can have catastrophic consequences. But let's be realistic. Implementing EID in practice is probably not a walk in the park. What are some of the challenges the paper highlights when it comes to actually designing and implementing EID interfaces?
Yeah, you're right. There are definitely challenges. One of the biggest hurdles is ensuring that the designers themselves have a deep understanding of the system's constraints and how those constraints relate to the different levels of the abstraction hierarchy.
Right.
If the designers don't have that deep knowledge, the interface won't accurately reflect the mental model.
Okay.
And it could actually do more harm than good.
Oh, that's a scary thought.
Yeah.
So it's not just about slapping on a fancy visual representation.
Right.
It's about a deep understanding of the system's underlying logic
Yeah.
and how that logic translates to human cognition.
Exactly. It requires a close collaboration between designers, engineers, and the operators themselves.
Okay.
The interface needs to be grounded in the operator's real-world experience, their understanding of how the system works and how they interact with it on a daily basis.
That makes perfect sense.
Yeah.
Now, before we move on, I want to touch on something you mentioned earlier, the potential for EI to be applied beyond industrial settings.
Yeah.
Could these principles be used to improve the design of everyday interfaces, the kind of technology we interact with, on a daily basis?
That's a fantastic question, and one that the authors themselves raise in the paper. They acknowledge that EID was initially developed with complex industrial systems in mind, but they also hint at its broader applicability.
Okay.
As technology becomes increasingly complex and integrated into our lives,
Huh.
from smartphones to smart homes, the need for interfaces that support human cognition becomes ever more pressing.
Mm-hmm.
So, could EID principles help us design interfaces that are more transparent, intuitive, and empowering, even for everyday tasks?
I think that's a topic for another deep dive.
Yeah, definitely.
But for now, I'm really curious to delve into the specifics of the experiment they conducted.
Okay.
What were the actual tasks they asked the participants to perform?
So the experiment involved two key tasks:
Okay.
recall and diagnosis.
Okay.
Participants were shown dynamic event sequences on either the physical or physical functional interface, and then asked to recall the final state of various process variables.
Okay.
So this tested their ability to, absorb and retain information presented in different ways.
Makes sense.
The second task, diagnosis, required them to analyze the event sequence and determine whether the system was operating normally, experiencing a fault, or behaving randomly, defying physical laws.
Okay, right.
This was the real test of their knowledge-based problem-solving abilities.
And as you mentioned, the participants using the physical functional interface, the one that represented the abstraction hierarchy, performed significantly better on the diagnosis task,
They did.
especially the experts. What other insights did the experiment reveal? Anything that surprised you?
One of the most intriguing findings was the strong correlation between memory for functional variables and diagnostic accuracy. Participants who could accurately recall the state of those higher level functional variables, the ones that reflected the system's overall goals and functions, were also much better at diagnosing the system's state. Interestingly, there was no such correlation for memory of physical variables.
Hmm. That really highlights the importance of understanding the why,
Right.
the functional relationships, as opposed to just memorizing a bunch of data points.
Exactly. It suggests that the functional information provided by the abstraction hierarchy is essential for building a coherent mental model of the system and using that model to solve problems effectively.
Now, the paper mainly focuses on the benefits of EID for experts,
Yeah.
but I'm curious about its potential impact on novices.
Right.
Could EID also help those who are still learning the ropes of a complex system?
That's an excellent question, and one that the authors acknowledge as an area for future research.
Right.
They hypothesize that EID could potentially facilitate, skill acquisition by providing novices with a clearer understanding of the system's structure and function.
Okay.
However, more more research is needed to confirm this hypothesis
Right.
and to determine the optimal ways to adapt EID principles for different levels of expertise.
Yeah, it makes sense. If you're just starting out, having the clear representation of the system's logic and how everything connects could be incredibly helpful in building a solid mental model.
Precisely. It's like having a guidebook
Yeah.
that helps you navigate the complexity of the system, even if you're, not yet an expert.
Right, right. Before we wrap up our discussion of the experiment, I wanted to touch on something that caught my eye. The inclusion of those random trials where the system behaved in ways that defied physical laws.
Yeah.
What was the purpose of those trials? Did they provide any unique insights?
Yeah, those random trials were a clever way to isolate the effect of the abstraction hierarchy on memory and problem solving.
Okay.
So remember, the two interfaces differed only in their representation of functional information.
Right.
So by presenting participants with nonsensical random behavior, the researchers could ensure that any differences in performance weren't simply due to the visual appearance of the interfaces.
Ah, I see. It was like a control condition to rule out any confounding factors.
Exactly. And the results were quite telling. Memory performance on those random trials was significantly worse than on trials where the system behaved in a meaningful, physically consistent way. This suggests that the abstraction hierarchy provided by the physical functional interface helped participants, organize and retain information when it was grounded in a coherent mental model of the system.
So it wasn't just about making the interface prettier or more visually appealing.
Right.
It was about providing a framework that made the information more meaningful and memorable.
That's right. The abstraction hierarchy acted as a kind of cognitive scaffolding, helping participants, make sense of the information and integrate it into their understanding of the system.
Okay, we've covered a lot of ground today, exploring the theoretical foundations of ecological interface design and delving into the experiment that provided initial support for its effectiveness. We've discussed its potential benefits for both experts and novices, as well as its potential applications beyond industrial settings. But before we wrap up this deep dive, I think it's important to reflect on some of the challenges and open questions that remain in the field of EID research.
Yeah.
What are some of the key areas where further investigation is needed?
Well, one area that immediately comes to mind is the question of scalability. The experiment described in the paper focused on relatively simple simulated system. How do we apply EID principles to real-world systems that are vastly more complex with, thousands or even millions of interconnected components?
That's a critical challenge. And as you mentioned earlier, the success of EID hinges on the designer's ability to grasp the system's constraints
Yeah.
and to build an accurate abstraction hierarchy. How do we ensure that this process can be scaled to handle the complexity of real-world systems?
Well, that's a question that will require innovative approaches to knowledge engineering and system modeling.
Hmm.
We may need to develop new tools and techniques for representing and visualizing complex systems in ways that are both comprehensive and comprehensible to human designers.
And what about the role of artificial intelligence in EID?
Hmm.
Could AI be used to assist in the design process, perhaps by automatically generating or refining abstraction hierarchies?
That's a very interesting possibility. AI could potentially play a significant role in automating some of the more tedious aspects of EID design,
Right.
freeing up, human designers to focus on the more creative and strategic aspects.
Okay.
However, we need to be careful to ensure that AI is used in a way that enhances rather than replaces human expertise and judgment.
That's a crucial point. EID is fundamentally about supporting human cognition,
Yeah.
and we don't want to lose sight of that goal in our pursuit of technological advancements.
Absolutely.
Okay, I think we've covered the key challenges and open questions for now. Before we wrap up this deep dive, I want to give you the last word. What's the most important takeaway you'd like our listeners to leave with today?
I think the most important takeaway is this. Ecological interface design is not just about making interfaces, prettier or more user-friendly.
Yeah.
It's about fundamentally changing the way we think about human-machine interaction.
Right.
It's about designing interfaces that are truly in tune with human cognition,
Ah,
that empower users to leverage their skills, their knowledge, and their experience to interact with complex systems in a safe, effective, and even enjoyable way.
that's a powerful message and one that I hope will inspire our listeners to explore the world of EID further. Thanks for joining us on this deep dive.
It's been my pleasure.
And to our listeners, thank you for joining us. Keep those requests coming and keep exploring the world with a curious mind. So we've been on quite a journey with ecological interface design, exploring its theoretical underpinnings and the evidence supporting its effectiveness.
Yeah, for sure.
But I think it's important to understand how EID fits into that broader landscape of interface design. The paper spends some time comparing EID to other approaches. What are some of the key distinctions they make?
Well, one key comparison is with the concept of direct manipulation interfaces, or DMIs.
That makes sense, given that EID seems to kind of build on some of the ideas behind DMIs.
Right, yeah. But EID goes a step further. While DMIs focus on, visual representation and direct interaction, EID delves deeper into the cognitive mechanisms that make those interactions effective.
So it's not just about making things, look nice and easy to click on. It's about understanding how those design choices actually impact the way our brains process information and make decisions.
Exactly, yeah. EID, grounded in that SRK taxonomy, explains why direct manipulation works, and it offers, more specific guidance for designing interfaces that support those different levels of cognitive control.
Another concept they discuss is object displays. What's
Mm.
the connection to EID there?
So object displays emphasize presenting information in a way that reveals the relationships between elements,
Hmm.
allowing users to grasp those higher order properties directly. This aligns perfectly with EID's second principle, which stresses the importance of mapping system constraints onto those perceptual cues in the interface.
So it's about designing interfaces that let us, see the underlying structure of the system rather than just presenting a jumble of data points.
Precisely. And this relates to another key distinction the authors make. They critique what they call technology-driven display design, where interfaces are often driven by, the latest technological bells and whistles without sufficient consideration for human cognitive needs.
Yeah, it's easy to get caught up in the excitement of new technology. So it sounds like EID takes a more grounded, human-centered approach.
It does, yes. EID starts with an understanding of human cognition and then considers how technology can best support those cognitive processes.
Now, when it comes to Representing the complexity of systems, they also compare EID with a couple of formalisms, the operator function model or OFM and the goal means network or GMN. What sets these approaches apart?
So the OFM focuses on operator actions, representing the tasks and procedures involved in controlling a system. It's well suited for, highly procedural domains where actions are predictable.
So OFM excels when there's a clear set of steps to follow,
Right.
a well-defined path to achieving a specific goal.
Exactly. The GMN, on the other hand, is more similar to the abstraction hierarchy.
Okay.
It represents the functional structure of a system and how components contribute to overarching goals.
And where does EID's use of the abstraction hierarchy fit in? What makes it particularly suited for complex systems?
The authors argue that the abstraction hierarchy's multi-level representation is ideal for supporting knowledge-based problem solving,
Mm.
especially when those unforeseen events are a concern. It provides operators with a deeper understanding to diagnose and resolve novel problems, empowering them to think critically and adapt to dynamic situations.
We've covered a lot of ground in our deep dive into EID.
Yeah.
As we wrap up, what's the key takeaway you want listeners to leave with?
I think that the core message is this. Ecological interface design is about designing for the human mind. It's about understanding how our cognitive processes work
Hmm.
and creating interfaces that leverage those strengths. It's not just about making interfaces, more usable.
Yeah.
It's about making them more powerful, empowering us to interact with complex systems in a way that is both intuitive and insightful.
It's a powerful idea, designing interfaces that enhance our ability to think and make decisions rather than simply presenting us with data.
Yeah.
Thank you so much for guiding us through this deep dive into EID. It's been truly illuminating.
It's been my pleasure.
And to our listeners, thank you for joining us. Keep those requests coming and keep exploring the world with a curious mind.